Let's do these problems right here. The question is asking determine if S is a subspace of R3. Let's see, check how we can do this. So first of all, if something in order to be in Rn, it has to be subspace of Rn and it has to satisfy three conditions. That's what I'm doing the first question. So three conditions. It has to have a zero element, and second one is it has to be closed under addition. Closed under addition. And it has to be closed under scalar multiplication. The scalar multiplication. So let's check the first condition. So it should has a zero element. What does that mean is when you substitute zero for everything, you get zero for like zero all in everything. So in this case, if you substitute 0 for x, 0 for y, minus 0, so it's giving 0, 0, 0. So it's satisfying the first condition. However, we have to check the other two. So let's see. For example, in this case, what you can do is, so there are two ways to do this. If it satisfies the condition, almost satisfy the condition, we have to always take alphabetical values, but in this case I know this is not satisfying because let's pick up a value that gives us 0. So let's say 1, 1, 1. 1 times 1 is going to be, so this basically means that multiplication of first two values minus the third value should give us 0. So that's why I pick 1, 1, 1. If I multiply 1 times 1 minus 1, that will give us 0, right? But if I multiply that one by 2, will it give us 0? 2 times 2 minus 2. It is not giving us 0, like 4 minus 2, it's 2, it's not 0. So I know this is not a subspace of R3, therefore I can do the third one. Third one is much easier to prove in this condition. So let's pick up the third one. So I'm taking 1, 1, 1, and if this is 1, 1, this is belong to subspace. If it's belong to subspace, then we have to prove that 1 times 1 minus 1 is equal to 0. That's true. So 0, 0, and it's scalar multiplication. 2 times 1, 1, 1. I'm getting 2, 2, 2, and 2 times 2 minus 2 is not equal to 0. Therefore 2, 2, 2 doesn't belong to subspace. Therefore not closed under scalar multiplication. Therefore this is failing this condition. Therefore S is not a subspace of R3. So let's do the other one. Second question. I have to check the same thing. 0 element, and then closed under addition. Closed under scalar multiplication. So let's see whether it is true for this one. So first of all, 0. If I substitute 0, I am getting 0. So that satisfies the first condition. 0 minus 2 times 0 plus 3 times 0 equal to 0. So we have a 0 element. Then as I said before, we can check for any real number by mind, like scalar multiplication, by simply doing within my mind. For example, if I pick minus 1, I have to pick a value that will give us 0. So minus 1, 1, 1 will work. Minus 1, 1 1. So if I substitute, what happens? Minus 1, minus 2, minus 3. Minus 3 plus 3 is 0. So let's multiply that one by 2. So minus 2, minus 2, 2, 2. Minus 2 minus 2 times 2 is going to be 4. So minus 2 minus 4 minus 6. 3 times 2 is 6. That's gives us 0. So I have an idea that this is going to be a subspace of R3. So in this case, what I have to do, I have to choose alphabetical values to prove that it's true for everything. So if I want to prove, let's pick up a value like ABC. Let's say ABC belongs to subspace. Then I can say also I can pick up x y z belongs to subspace, and then if this is ABC belongs to subspace, what it should be satisfied this one. For example, this is what does it really mean? This is first value of this one substituted by second value 2 times and plus 3 times of the third value should give us 0. So it should be true to this one. So A minus 2 times B plus 3C should be equal to 0. Here it's same thing. X minus 2y plus 3C is equal to 0. So if this is true, it should be true for addition. So let's see. ABC plus we are adding XYZ together, ABC and XYZ. If I add them together, I will get A plus X, B plus Y, C plus Z. So this should be true for this one. So in this case, A plus X minus 2 times B plus Y plus 3 times C plus C should be equal to 0. Let's see whether it is true. So I can rearrange this. First let's get rid of this bracket. A plus X minus 2B plus 2Y plus 3C plus 3Z equal to 0. Now I have to rearrange this one like almost near to bring this pattern. A minus 2B plus 3C and other one is X minus 2Y plus 3Z equal to 0 is plus equal to 0. Now I know I can bring this value and substitute here. Also this one here, 0 plus 0 equal to 0. So this is closed under addition. Closed under addition, so it's passing the second condition. And the third one is I have to do the same thing for closed under scalar multiplication. So let's say k is a constant, belongs is any real number, and then ABC belongs to subspace. If it's ABC belongs to subspace, then we know that A minus 2B plus 3C should be equal to 0. It should be true for scalar multiplication. For example, if I multiply ABC by K, we will get KA, KB, KC. So we should prove that KA minus 2KB plus 3KC equal to 0. In this case, if I take K common, this will be A minus 2B plus 3C equal to 0. So if I can substitute this one right here, so K times 0 is 0, therefore 0 is 0, closed under scalar multiplication. Closed under scalar multiplication, I can say tick mark here. Then therefore we can say therefore S is a subspace of R3. And that's how we prove this kind of question. I hope you guys like this video. See you next time.